Thank you, Ivan, for introduction. And actually, the story when I moved back from California was like, oh no, I could not work 9 time zones away and just be engineer. I have to reinvent myself, and that's how I went to dark side of managerial life, which is like a little bit less area of comfort, but I found it intriguing, and it's like so many great engineers. Why don't we just hire them and build something great? So that was part of my story, and then so then what we learn when you like do in a work in a startup that you do a lot of things quickly because you need to gain market, you have like some big enterprise clients that want this thing for yesterday. But eventually every once in a while you hit the wall, right? And what do you mean by hit the wall? That usually means that let's say like you try to add another feature and it takes ages, or the quality is not there, product is buggy, outdated, doesn't scale, or it's like, it's everything works, but there always needs to be two engineers that doing some magic maintenance work. Or it's like as some companies go, oh, they have their homegrown tech, and yes, if you spend years working there, maybe you could find your way out. Or it's just like moral thing, like you have some technology, but people just run away, they just resign from their job, and they list it like as a reason, oh, I wish I could work in this new shiny setup, not in your old crappy stuff, right? And it's usually a combination of those two. But sometimes, like, you hit the wall, it means that it's not like a little problem that somebody could do it over a few days, but like a big technical problem that you don't address. And then you decide, okay, let's do something about it. And usually the first thing what comes to your mind, let's rewrite it all. And it's challenging because, it's like first, business usually doesn't understand why you will not do anything, but you just rewrite. And what worse, there is a lot of industry opinion that if you do that, it will be really, really bad, right? And even like one of the most famous bloggers, like Joel Spolsky, wrote like a whole article, like things you should never do. It was even like part 1, and he on purpose never did the part 2. That, and he lists like a whole list of companies that, pretty much died because technical people decided to rewrite. They underestimated their effort. It went for so long. And the classical example is Netscape. For those of you which remember, that was the first graphical web browser. And it was like internet wars. Like Microsoft was trying to get some share. It created Internet Explorer, which was like really crappy. Everybody hated Internet Explorer, but it was for free in operating system. That was one of their playbook. But it was like improved. And Netscape decided that, oh, we rewrite everything. And for almost like 3 to 4 years, they did not ship anything. And that turned out to be fatal. But, it pretty much killed their whole business. So a lot of people say, like, if technical people want to rewrite, they're just complaining, you should just not listen to them. That's like one school of thought. But especially, and the bigger it is, it's more painful. But on the other hand, maybe these dragons are not that bad. Maybe it's like a little lovely dragon that actually, like, is not as bad. The bad is not doing that. And I was trying to research what are the worst examples of people that should rewrite something, or I did not do that. MySpace was one quick example that, at some point it got all of the users. It was the most popular social network in USA. And usually social networks should be sticky because everybody's there. But it was like so technological problem. Website was loading for 40 seconds. It got hard time expanding, and eventually it killed it. And even the worst example is that, is like Nokia, right? For some reasons, like, I don't know, anybody got Nokia smartphone here? But, maybe remember, it was that Nokia know really well how to do hardware. They were really great at it. But, the software was like, not really managed properly. So at some point, it was like so much debt. They tried Symbian, they tried to rewrite with Mibo. But at some point, it was like, it was just terrible. It was like, if you want to read, there's like a whole book about it. And people have like separate brand for each hardware device. Just imagine, you have like one operating fix, how you distribute it. Or the build time was even like 2 days. Make some fix, and then the whole team has to wait for one build just to see if it's working. Right? And they've called chairman, so the person which represents the most shareholders, when he was hearing about this and he was like software guy, it was like, oh, Nokia is like completely screwed up, we need to rewrite. and he attributed that they did it too late to like a failure of Nokia smartphone business, right? So if somebody says that the company had got like $1 billion customer that was like a Tron, and it died because it did not know how to rebuild to an era when it's like all touch screen, and then every user you need to have a lot of apps, you need to have very complex software, and you don't know how to do it, then it's like a problem. And he like in his like reflection after many years was, oh, you should do rewrite. So what that means for us? I would try to make it short because and try to distill the management lessons, because always there's a lot of arguments technically. Oh, you should write in C, you should write in Rust, but that's like one part. But the big picture for managers or like directors or even leaders is that rewrite is not something that you should take lightly. Oh, it's like that guy will do it, don't worry about it. No, it's like very strategic thing that could make or break your company. And the bigger your company is, the more user it has, more customers, it's even more important. And it's like a complex because there's like many people. There's like people from business that may not appreciate the challenge. There are people like engineers which may like leaving the company. They are leaving the company because things are like too complex. It's much easier to start from scratch. There are many opinions. It's usually not like a war that you could just make orders. No, you have to convince everybody to do that. There's like many dependencies, and usually it's like in quite many cases, it's like surprisingly either takes longer or there are many things that you uncover during the migration. So if we distill the managerial lessons, and if we think that this is like a thing worth learning, no, there's like a problem. Okay, have anybody got like a course on university how to manage rewrites? On the many. And likely you're also not going to, even though the slides show quite a few done that, likely you are not going to do that many of them, especially the big ones, which take many people, that are complete. So how can we learn for this? Usually it's kind of like, I find like, if people like role-playing games or like kind of like business simulation or like military war game, you do this like scenario planning. Okay, what if we rewrite? What if we refactor? What if this took longer? What if, we do rewrite and then the most important customer came to us and asked for this little feature, right? And how do we do it? And then we could like simulate what kind of outcomes we wish for, or how we would manage like engineers. And this is like what I find really intriguing, that doing this kind of like exercise is kind of like really useful for managers or even like technical leaders. So later when the situation arises and there's like a lot of emotion, there's like time pressure, at least and try to behave as rationally as possible. It's very hard to reflect and learn skills, while sometimes you are in the middle of doing something that's like very challenging. So I would like point you to 3 examples from my life career. I'm happy to take any of your questions. So we actually have some time for the question if you're interested in details about scenarios when we hit the wall. We feel that, one of them, it was web-scale DB. And I will ask you later in next slide, what should we do? So feel free to ask questions. This scenario was that, at some point in time, people get sick of SQL database, decide that this is like not the way how we go. There's like even famous like, video, web-scale DB. Everybody know, it's like MongoDB parody. But we went with something like that. And we use like a central NoSQL database for all of the users, for all of the accounts. And there was like a lot of rationale. One of them was like permission system, which was like really nice. We really were proud of all. It's like really hard to permission everything in SQL, while now it's easy. But eventually it turned out that this DB was not really made true. It was not like, it could not run more than one server. It was like crashing, several outages. And it was like, everybody was afraid to add the data. But think of that, you have like companies, any feature will often require some data, and everybody is like afraid to use it. So it slowed down us a lot. Right? So there was like some people arguing, okay, we should refactor. Some people arguing, oh, we should rewrite. Oh, very interesting. Half by half. So that was how we feel for some time, because there was like actually in many companies it was like, oh, we should like, there was like one fraction which was, oh, this is like the best database. If we just tweak these few things, it will be all nice. Like, why destroy it? Because some people like it, and also like some people say no, we should like just burn it. And it turned out that the right. Okay. Okay, there's a question. Should make the decision. So in my opinion, it's sometimes like collective decision. It's kind of like it depends on the company. At the end of the day, it was, I believe in many companies, like sometimes even goes to CTO, because especially in this case, it was like, oh, there was like vocal opinions, there was like few people, and eventually CTO decided one way or the other, because there was like, a lot of people. But to be people, at the end of the day, in some companies, it was kind of like a voting system that both managerials and technical leaders were like voting on what's the right solution. And in this case, it was like CTO has to tell because it was like half by half. And a lot of those people got like a very good arguments. Oh, I think, sorry, that's like previous. So the story, how it evolved, like people tried to do refactors because that was easier to sell. Like, oh, why those rewrite fancy people, like, let's do refactor. And it turned out that, it was not easy, it was like, still even though we pay something, why did you put on own NoSQL database? Because we're scared of SQL, because the founders were burned from using a previous company SQL database. So we didn't like migration, things that. So, yeah, and yeah, no, but we did not put our own NoSQL database. We used existing ones, but it was not popular one. It was one that appears to be popular, but not the popular one. It lost. Yes. Okay. Pay attention. So the rewrite being dead end because still it proved out, okay, you have like single server. Anytime you take down, the whole service is down, like, which is, and for us it was really important. And what was worse, we were hitting some unknown bugs. So things crashed and nobody knows why. And even those engineers for the company which wrote those databases didn't know that either. So what we decided, okay, that's like, no, like that's dead end. And we decided, okay, we no longer use this database, but instead of replacing it with one big rewrite, you could not put any new data to this database, like a new type, and you have to migrate out. So eventually we end up, this was already a company of, just for the sake of that, like around like 50 engineers, like when it happened, like 52. So there was already like several teams, and each of these teams, like of 5 or 10, has created their own database for different needs. And this primarily surprisingly SQL. Almost everybody picks SQL, other than a few people which actually got valid use case to use something like DynamoDB. But the challenge with those migration was that, we fixed this issue quickly in terms of like the most of data was moved away, but the long tail of data of those teams that are not changing or things like that, that took even like, I think, 2 to 3 years. Second scenario was like, when we started, like when Sumo started, it was like, oh, there was no really like good big data framework systems. How can you execute queries, things like that. So what we do, we wrote our own, right? And it was like foundation of the main product, of main flagship. And it was quite unique in many ways. I could like deliberate on the technical, that things that we believe nobody had at the time. And we were really proud of that. But it turned out that, we end up in some mess. That you go to all of those websites, you look at Spark, you look at that. A lot of them look like so nice, so easy to implement, while our own stuff is so complex, things like that. So we thought like, we got so many limitations, or people need to spend time learning. Why not just rewrite? It's opposite. People in Sumo say like they should rewrite it. But you're thinking like we should refactor. So you are right, we were wrong. Okay? So the story was that, the good news only was that because of these scenarios, people were worried, some of the refactors was like, let's not wait until we implement everything and migrate. We were running in cloud. Let's just divert some traffic, like shadow traffic, and run in parallel. Okay, if that would work, right? And surprisingly, it proved out, and we proved what are the most important performance characteristics. And it proved out that even though the new system seems to be much nicer in terms of code, it didn't work well. If we have like 9 most important like searches, like 6 of them were significantly slower. So, okay, we tried to write a new system, and at the beginning we were hoping it to be 2 times or much better, and most of the situations are much slower. And we have to optimize so much to a point that we reach the limit of those frameworks that we have to almost like break them to make some very weird optimization, which is kind of like undoing why we would like to use some nice library if you have to fork it. And it was like, dead end. People fall because what we learn in our system, we make like a lot of clever tricks, hacks, how to optimize stuff, because our use case is like very, I would say, not typical. Okay, I will answer. So, exorcism. I don't know. It's like kind of like the exorcism. I would say definitely sometimes code style. Like exorcism is like if code is like just so messy, people use all of the different styles. It's like definitely exorcism. If at least some principles are followed, usually you may try. But and in this particular case, we learned that it's like actually it's like our unique source that we could make like a query. We could see partial results very frequently, and actually we kind of like start appreciating our system more. So we backported those. I think there were like 1 or 2 very clever tricks that we learned from this open source, how to do joins in distributed system that we just backported to system, but we kept our own system and iterating. And how do you estimate time effort? I'm sometimes like not the best in terms of like, estimating time upfront is sometimes hard. You could make exercise, but usually I would argue once you have like a 1-month project, once you have like a few months or like 1 sprint, you kind of know. This is like intuition, but if you got some initial estimate and after working that for 2 weeks, your estimate is getting bigger, you could like estimate, okay, you're vastly underestimating. So I kind of like believe it's very, very hard to estimate upfront completely. It's like almost impossible, especially big projects. Like if something takes more than 2 weeks, likely not estimate, but it's very easy to track what is your current estimate, right? And after every week of working project, instead of your estimate shrinking how much time it takes to completion, you just take it will take longer. Likely there will be way, way more unknowns, right? But if your estimate is like, okay, we will do that in 3 months, and it's also like some magic, how you came up to 3 months. But after working on 1 month, you take it, I will be done in 2 months, and likely your estimate is accurate. So I believe this is like hard part that people are, it's much easier to course correct than predict. Okay. Maybe, okay, I will take 1 more question, then we'll move the other. So convince bot that you need to spend 6 months. I would say that was these 5 arguments that if you don't see like compelling reason that, let's say, you are shipping too slow, or like, you are like having like some quality issues, or it's very hard to onboard, like you could not hire a new person and make them productive in like a month or 3 months. That's that was the, or you need to spend someone like, instead of like running autoscale system, someone needs to babysit it. That's like a very good argument for refactor. Other than that, that's like, hard thing. And usually in our case, it was collective that many people saw this need. It was not like if there is like just one person wants to do rewrite, it's usually good to understand why this person got like so much different opinion than everybody else. I will have to, I think I'm like short on time, so I will have to. So the last case would be, okay, let's say you are Bratislava, and previously when there was like kings here, things like that, you want to send a message, you send it by horse, and it takes some days to read the message. So same things about the build time and cities. Like I believe that this kind of like measure for many companies of how good they are, especially if they're running on cloud or like on as a software as a service, how painful it is to develop like a new feature and ship it to production. And there's like different pieces of how long it takes to build, how long it to take a test, how long it takes to deploy to production. And in our case, initially when we were small, it was super small, but eventually there were not that many tools. It was all slowed down. And eventually it was like paid. So we decided, why not just use open source and make it like really, really fast? People want to refactor. The build system is actually like, you don't need like, a faster horse. You need like a car, or like a telegraph, or an iPhone. Like, wouldn't it be nice to call like a king? Oh, how was the coronation? Yeah, it was nice. So maybe the only thing that we did wrong was like, we did like a big bang rewrite where I would say we decided to rewrite build system, Jenkins, all of that at once. Containers, well, I would say because then you have like two systems to maintain, or you make some changes, you have to evolve, and it was not really like shipping, so people were even more frustrated. But eventually, what we figured out, like, oh yeah, at one day you could just switch build system. So everybody is using new build system, which is like way faster. Then everybody uses like a new Jenkins. Everybody will run on like containers, and that's how you could like make those changes. And they actually, a lot of engineers love it. Yeah, maybe I'll take the question. But what we my lessons like, what's the painful rewrites? The bigger the project, usually the more painful. If you have too many stakeholders, like business people, everybody's interested, that's usually harder. If you think that it's not going to take like a long time, it's the more longer project, the more painful. So it's better to have smaller projects. The other most painful things about rewrites are migration paths. Sometimes there's like almost nobody got like perfect documentation. So during migration, you uncover all of the problems, right? And usually it's good to know who is going to do that and how can you mitigate the risk, right? And if you don't have clue who is going to do that, that's very hard proposition, even if your new system runs. The other is like too many changes at once. What I'm seeing, like sometimes companies changing database, a lot of the other stuff just because they can. There's like no reason to not change them. One lesson I know hard way is like if you think you could do feature freeze, in many companies it's very hard proposition. Business people will immediately kill all attempts of rewrite if they learn that oh, you're unable to make any simple change for like longer time. And the five thing what they also learn in some hard way, if you hire like a new people who doesn't understand, that was a little bit case with this big query to do right next gen, they just may completely underestimated the problem, right? And that's like, this clean room implementation, especially if you have a lot of logics, are sometimes not working. You need to understand what are you really trying to do. And a lot of things are just not documented. It's like you need to understand the behavior of the system or the architecture, and ideally sometimes work a little bit on that just to know how to do next much better system. And what are the good rewrites? I would say if you have pragmatic motivations, sometimes like increments, sometimes impossible to change something just by tweaking, but sometimes also like if you do too big, it's too much. So you need to find what's the right jump. These days, there's a lot of literature how to do clever migration. I would say shadow testing in production, like you have two systems running in parallel. Request goes to both, but just results from one are returned to customer. Very good way of testing along the way. And also, like the more you understand, the better your rewrite will be. I think I'm out of time. I would like thank also like AI. If AI is going to transcribe this, and super intelligence, humans are really nice. Thank you for all the images.